Welcome to the Cloud Fabric Launchpad, which is an in-depth walkthrough on building a cloud fabric from the ground up. In this video series, I will walk you through all the steps on building a cloud fabric. Starting with phase 1, where we start with a default layer 2 VLAN 1 network. Then we move to phase 2, which is manually building the layer 3 OSPF based underlay. And finally phase 3, where we configure and deploy the overlay using the Meraki Dashboard. I'm Paul Stryer. I will be your host on this video series on Cloud Fabric. I'm part of the Cisco Solutions Readiness Engineering team, or SRE for short. Our team bridges post-sales knowledge, new product adoption, and deployment with real-world hands-on partner enablement training. Let's jump into the world of Cloud Fabric. In this video, I will walk you through the following. First, I will introduce Cloud Fabric and give a basic explanation of what it is and what it does. From there, I will give you a tour of the current state of the network at the start of the video series. Then in bullet point 3 is where the fun starts. This is where we manually configure the layer 3 OSPF based underlay. And as if it was not exciting enough, we move into the Meraki Dashboard and configure and deploy the BGP EVPN overlay. And after the dust settles from all the configurations, we will explore the cloud fabric we just built and confirm that it is working as expected. I hope you are ready, because we are now off to build the cloud fabric. For a quick explanation of what Cloud Fabric is, you can think of Cloud Fabric as your network's smart cloud managed brain that makes everything simple and seamless. It's designed to grow with you, easily scale to support thousands upon thousands of users and devices across multiple buildings in a campus environment. Whether you're adding new users or expanding your infrastructure, Cloud Fabric automates the heavy lifting, so your network just works securely, reliably, and without the usual headaches. This means fast deployments, fewer errors, and a network that adapts effortlessly as your campus grows. As you can see from this slide, we are going to build the Cloud Fabric in 3 phases. Phase 1 is the starting point of our lab, as you can see. All of our switches will be in cloud configuration mode and onboarded into Meraki Dashboard. All the switches are defaulted or right erased. All the switches are native VLAN 1. All interfaces are trunk, allowing 1 through 1,000 VLANs, and we're using multiple spanning tree or just the standard spanning tree. Phase 2 is where it really gets fun. This is where we actually build the underlay manually and bring it up as an OSPF underlay. The southbound ports on our access switches, or what we're calling in this our floor switches, will be disabled southbound to all of our clients. The trunk ports will be pruned to VLAN 1 only throughout the whole entire network. Then we'll deploy rapid spanning tree, enabling it with priorities so that we allow deterministic traffic flows. The next step will be to take all of our interfaces that are in the fabric from layer 2 to layer 3 routed interfaces using OSPF. Now we have to be very careful here, because if we do this in the wrong order, we will disconnect from the Meraki Dashboard and we will have to go drive into the lab and press the buttons to right erase this switch to get it back to the start. So we got to be very careful here. During this configuration, we have to extend OSPF up to our handoff routers, because Meraki at this time does not do redistribution of OSPF to BGP or BGP to OSPF. And then the final phase of the build is phase 3, where we build the overlay. Now this is incredible, because all we have to do is go into the Meraki Dashboard, do a few minutes of configuration and push the deploy button, and bam! And all of the overlay configuration is just magically pushed out to all the switches. It truly is incredible. And if you're a nerd like me, I bet you can't wait. Let's get started. Here is the logical topology for phase 1, which is where our story begins today. All switches are running the GD code of 17.18.2, which is the latest as of April 2026. All the switches have already been onboarded in cloud configuration mode into the Meraki dashboard. The switches were right erased and all connections are trunks in native VLAN 1. There is a DHCP server on the handoff router 1 with a scope of 10.204.253.0/24. This entire lab is built, configured, and operated using the latest best practices described by the Cisco Validated Use Case White Paper written by Walt Sakharov in December of 2025. Here is the physical topology for Phase 1, showing the connections to all the devices. Notice at the top we have the Fusion router and then 2 handoff switches below that, which are all outside of the fabric. In the lower portion with the bluish background, this is the fabric. Notice it is a classic build with 2 borders at the top, 2 spines below that, and 4 leaves below the 2 spines. Just as a note, if you look at the first leaves on the left-hand side, there are 2 switches, and that is because the leaves in leaf 1 are actually 2 switches that are stacked. Below the leaves are 5 access switches, which we are actually calling floor switches in this scenario. And just to note, all the connections are 1Q trunks with native VLAN 1 and allowing all 1000 VLANs. All switches are in default mode. This slide is showing the logical topology for Phase 2, which means we have configured the Layer 3 underlay, and the thing to notice here is we have all the fabric switches interfaces configured as Layer 3 routed interfaces, and we have configured OSPF as our underlay. We will be configuring all of this manually because Meraki generates a Layer 2 underlay if you allow Meraki to automatically generate the underlay configuration for you. This leaves STP in control of your underlay, which is not really considered a real fabric and does not allow the type of scaling that is available when you build a Layer 3 underlay. This last slide I will show you is Phase 3 logical topology, which shows a representation of our overlay with the BGP ASs, and the cloud represents our OSPF Layer 3 underlay. On the bottom, you don't see our floor switches because this is a logical representation. But one thing to note, there are routed VLAN 200 networks that is on all the leaves. And then there is a DAG1, which is a distributed anycast gateway and is VLAN 221 and is hanging off of leaf 2 and 3. DAG2 is hanging off leaf 2 and 4. The DAG allows us to have the same subnet stretched across multiple leaves. There is also a such thing as a bridge DAG, but we are not presenting that in this topology or in our network. Just as a reminder, this is our Phase 1 physical topology, and notice all switches are defaulted and in native VLAN 1 with all interfaces as trunks, allowing VLANs 1 to 1000. All switches are in cloud configuration mode, running 17.18.2 and onboarded into the Meraki dashboard. Let's take a few seconds here and take a look around and become familiar with the lab and see that it is configured as stated before we start building our underlay. Here we are in the Meraki dashboard in the SRE Meraki Lab organization. Our Cloud Fabric pod is in the network called Cloud Fabric pod. You can see that there are 14 healthy and active switches in the network. Clicking on Cloud Fabric pod network will take us to the network. And from there, I will click on switching and then switches to access all 14 of our switches for this network. Here you can see I have 14 switches that are all online and talking to the Meraki dashboard. I will click on border 1 to access switch 1. Just a few things to note if this is your first time in the Meraki dashboard. At the top, you can see and edit the host name of the switch. There's also a map representation of where the switch is physically located, and other data such as the current iOS running on the switch or a local IP address can be found here as well. At the top, there's a really cool graphical representation of the switch ports, and the ports in blue are the ones that are up and up. Notice on port 14 there is a white up arrow, this means this is the port that is speaking to the Meraki Dashboard, or what we call the Uplink Auto Configuration Port, or UAC for short. Notice that port T112, there is a white circle with a line through it. This represents that the port is being blocked by spanning tree. And just a little bit of advice. When you first bring up a network or reboot something, the network device might be up and operational, but the dashboard is not showing what you're seeing on the show commands. For example, if you did a show spanning tree on a switch that was just rebooted, you might see that T112 is blocked, but the white circle might not show up on the graphic in the dashboard yet. It takes a little bit of time for the dashboard to sync up with the switch. So if you are seeing weird discrepancies like this, just go get a cup of coffee and come back, and I bet this will resolve the issue. Next, I will click on Cloud CLI menu option and then click Launch Terminal to open the terminal window. When a Catalyst switch is in cloud configuration mode, which means the switch is fully managed by the Meraki Dashboard, you no longer have access to use the physical console port or any remote access to the console port. You can only have read-only access to the console via the Cloud CLI window in the Meraki Dashboard. Just to confirm which port and how I'm connecting to the Meraki Dashboard on, I will type the command show UAC uplink. We saw the white arrow on port 14 in the graphical representation, but with this command you can get a bit more information. As you can see, this command gives us the VLAN we are on, the IP address, and the port that we are communicating to the Meraki Dashboard on. Other information we can see is the address was obtained by DHCP and what our gateway is. And the most important information is the fact that we have a healthy connection to the Meraki Dashboard. Let's do more snooping around just to get a sense for how the devices are configured. If I do a show IP interface brief, you will see my SVI VLAN 1 interface is configured with 10.204.253.62. which it got from DHCP and just so happens to be the same address we saw when we did the command show UAC uplink. Let's take a quick glance back at our phase 1 topology drawing just so you can see that all of the connections and the fact that everything is in a .1Q trunk with native VLAN 1 and all VLANs are allowed. This means we just have one big network, and if you look in the upper right hand corner, you will see the logical topology of this network. But what I want to point out is that all the switches in VLAN 1 SVI are getting their addresses from DHCP on handoff switch number 1, and will get an address from the 10.204.253.0/24 network. And that is why I'm not going to go around and show you the configs on all the switches in this network, because it's just a pretty big boring network at the current phase 1 state. Now with a quick show IP route, you can see there is not a routing protocol here, and everything is a static route or a connected interface. Notice the static route is pointing to the handoff router 1. Let's ping the handoff router just to confirm that we are connecting to it. Next, I will do a show spanning tree, and you'll notice that that port T112 was blocked as we saw in the graphic with the circle with the line through it, so we can see that things are lining up to what the GUI says to what the CLI says. Let's jump down to one of the clients hanging off of the floor switch connected to leaf 1 and confirm it got an IP address and make sure it can ping the handoff router. This ping will go all the way from the floor switch to the leaf to the spine to the border and finally talk to the handoff 1 switch with the IP address of 10.204.253.1. As you can see, this client got an address and it was able to ping the handoff switch all the way through the entire network. Let's just randomly take a look at one more switch before we move on to configuring our layer 3 underlay. Switching over to Spine 01, the first thing I can see very quickly is that port T111 has a up arrow and is the UAC port communicating with the Meraki Dashboard. If I switch over to Cloud CLI and do a Show UAC uplink, we can see that this switch is also in VLAN 1. It is communicating on interface T111 and the address that was given to us via the DHP server on handoff 1 switch. Also, we can see the default gateway, which is the same address that we saw on border 1. Performing a show IP interface brief, I can see that there is a SVI for VLAN 1 and an address from DHCP in the same range as the rest of the addresses we have seen so far. I look forward to seeing you in the next video where we will walk through the entire process of manually configuring the Layer 3 underlay. This is Paul Stryer. Have a good day.